So today's topic is on blood pressure and the things that affect blood pressure and maybe a little bit about how that happens. So we've already done a little bit of work with that a couple of days ago. You know, hopefully, that blood pressure is kind of influenced by three different things. One is cardiac output, which is in the first box here. The second one is arteriolar resistance, and then the third one is blood volume. And we're going to talk a little bit about how those different things actually affect blood pressure. So let's start with cardiac output. Last week you did a little lab and you tried to figure out what your cardiac output was. There's two things that determine cardiac output. What are they? Stroke volume, which is how much blood your heart pumps from the left ventricle with each pump, about 75 milliliters, 100 milliliters, depending on how strong your heart is. And then the other one is heart rate. So obviously, the harder your heart pumps, your cardiac output will be going up. So let's just remind ourselves a minute. If we increase cardiac output, so either probably by raising our pulse rate, that's probably the easiest way to raise your cardiac output, what is going to happen to your blood pressure? It's going to go up. So blood pressure is directly connected to cardiac output. The more blood you have moving through your system every minute, or the faster it moves, the more blood pressure your blood pressure is going to go up. So we can just talk about how does that happen. The easiest way for cardiac output to increase is exercise. So if you put demands on your heart, you need to deliver more oxygen, you have to get rid of more carbon dioxide, your pressure sensors are going to measure that, and you're going to have increase in cardiac output. This one is a little more complicated, the second one, arteriolar resistance. So what is that talking about again? What is arteriolar resistance? So it's simply the resistance in your arteries or arterioles to blood flow. In other words, if somehow your arterioles and maybe your smaller arteries start to resist blood flow, your blood pressure is going to go up because your heart's going to have to work harder to get that blood flowing through there. So pretty simple. Here we can just simply say if arterial resistance, we'll just put resistance goes up, what's going to happen to blood pressure? Well, that's going to go up too. But that one isn't so easy to always figure out. What kinds of things actually affect the resistance in your arterioles and in your small arteries? What kinds of things are going on in your body? So we're going to actually take a little bit of a look at that right now, and then we'll come back to that last one. So what we're trying to figure out now is, so what kinds of things make your arteries constrict or make that resistance go up? Well, I guess the first thing is number 2 here. You have to remember something important about your arteries and your arterioles. What makes them up? What's part of what makes them up? Well, it's smooth muscle. Your arteries, if you haven't read topic 10.1 yet, you need to do that. That's the one topic that I've kind of left for you. Have you filled in that chart I gave you now almost a week ago? If you haven't done that yet, you need to go do that. But if you have done that, you would know that your arteries and arterioles are made up of smooth muscle. In other words, without you having any control over that, because it's involuntary, those blood vessels can close and open based on what your body thinks needs to happen. So it's a uncontrollable nervous response to what's happening in your body. So one of the things that can change the arterial resistance is when nervous impulses and hormonal controls make your blood vessels either vasoconstrict, which means get smaller, or vasodilate, which means open up. So if we go back to our other chart then, one of the things we can put in here is that these are largely controlled by hormones and by nerves. Okay, so that's what controls this whole idea of vasoconstriction and vasodilation. So we're going to look at a hormone in a minute that is released when you exercise, and we'll be able to figure out what it does. So that's one thing to kind of make note of. And then the second thing to make note of is this one. There's a bunch of different kinds of things that can cause your arteries also not to open up. One is lack of elasticity. So as you get older, your blood vessels aren't as elastic anymore. They can't stretch as much anymore. The tissues are starting to deteriorate and become a little bit brittle and that sort of thing. So that's sometimes called hardening of the arteries. Maybe you've heard of some older people having that. And it simply means that when you need these blood vessels to open up, they don't open up as much anymore. They can't. They're not stretchy like they used to be. And so that would cause high blood pressure, which is one of the reasons why older people tend to have their blood pressures come up. So we can put as one of the causes of arteriolar resistance, we can put loss of elasticity. All right, another thing that can cause resistance in your arterioles is a disease called arteriosclerosis. So you probably know that arteriosclerosis is a buildup of plaque in your blood vessels. So you can imagine that, if you eat a diet, say high in saturated fat, it's going to stack nicely inside of your blood vessels, and the openings are going to get narrower and narrower. And because that is smaller now, your blood pressure will go up because your arterial resistance has gone up. So that's something that you can put down in this other chart. We'll just go really simple and say buildup of plaque. Okay, buildup of plaque. Another thing that we didn't even talk about so much is stress. Stress can do weird things to your cardiovascular system. If you're really stressed out, your body is going to make decisions about where to send blood. And your body always decides to send blood to the places of greatest importance. And so it'll send blood to your brain, and it'll send blood to your internal organs and that sort of thing. And it'll start shutting off a lot of the openings, a lot of the arterioles to blood, and therefore your resistance is going to go up. So stress can influence that. And then maybe the last thing just to take note of here is this. Things like cold temperatures, lack of exercise, obesity, those can all cause an increase either in cardiac output or in an increase in arteriolar resistance, and therefore you can end up with high blood pressure. And notice this last one. Most causes are unknown. So a lot of times everything will be perfect in your body. Your diet is good, you exercise, you're not overweight, you don't smoke, it's all good, and you'll still have high blood pressure. And they'll go, don't know why.
Joanna Cole, please come to the office. Joanna Cole.
So that sometimes happens as well. Okay. Let's just go to talk about this last one here. So blood volume. What can happen with blood volume? Well, we do know that if you increase your blood volume, in other words, if you just simply have more blood running around in your body, that's going to increase your blood pressure too. And one of the things that we will maybe talk about another time is the role that salt has in your diet. But if you eat a really salty diet all the time, salt can actually cause your body, your blood, to hang on to more water than it should. And that increases the volume of water in your blood. So in that sense, you've got more blood running through your body, and then your blood pressure is going to go up. So we'll maybe talk a little bit about that another time. Okay, a couple of last minute things. And then we'll try this blood pressure lab. So this doesn't go on the chart anymore. This is just something that we can take a look at that's also connected to blood pressure. So how does your body regulate blood pressure? Well, just, kind of like with the respiratory system, where it kind of regulated the amount of carbon dioxide and oxygen in your blood, your body does the same with blood pressure. So here's an example of these special blood pressure receptors in the walls of the aorta and the carotid artery. And you go, well, we've heard about those before. You also have O2 sensors in the walls of the aorta and the carotid artery. So when your blood pressure goes up too high, these little special receptors right in those two areas are going to help take care of that. How? Well, here's how. They sense high blood pressure. Nerves tell the medulla oblongata. Oh, good. We don't have to remember any other special parts here. It's the medulla oblongata again, that place in the base of your brain. Nerves tell the medulla oblongata that the pressure is getting hard, which in turn too high, which in turn sends impulses to the arterioles to dilate and the heart rate to decrease. And you think, okay, so how does that work? Well, think about this for a minute. When does blood pressure go up? When the arterioles constrict, so we may as well dilate them here. Let's open them up so that there's not so much resistance. And when's the other time that blood pressure goes up? Oh yeah, when the heart rate goes up. Well, let's slow the heart down. Let's slow it down. So your body does two really important things to keep that blood pressure just a little bit, get it to come down to normal levels. And then what about low blood pressure? You can have that as an issue too. What do you think? Just the opposite of high blood pressure. So you don't even have to write down for low blood pressure. You can just say here in number 5, opposite of high blood pressure. So that if you got low blood pressure, your blood vessels are going to constrict and your heart rate's going to go up. And now the blood pressure should come back up again. So that's something just to kind of know. You've got these receptors in your body that are going to help you help control the blood pressure. Okay, last thing, and then we'll do the blood pressure lab. What happens when you exercise? Okay, so let's take a look here. So when you exercise, we're going to throw in a new piece of anatomy here. We're going to throw in adrenal glands. So I got to remember these now. This is part of your endocrine system, so you really don't study this until Bio 30. All you need to know for this is that sitting on top of your kidneys are special glands called the adrenal glands, and they release a whole bunch of different kinds of hormones. But one of the things they release is adrenaline. So you've probably all felt a release of adrenaline at some point in your life because you've all exercised. So every time you exercise, your body releases adrenaline, but you've also experienced it with things like getting really scared really quick. You get startled, and all of a sudden you feel your heart rate coming way up really, really quick. And some of us don't like that feeling very much. It's an uncomfortable feeling. But that's just due to a release of adrenaline as well. So when you exercise, we'll just talk about this in just a minute, and then I'll grab your question. So when you exercise, the adrenal glands release adrenaline. It's also known as epinephrine, but just remember adrenaline is fine. And adrenaline does 3 things. So let's look at all the things adrenaline does. First thing it does is it releases red blood cells from your spleen. Oh, there's another piece of anatomy. So you got a spleen, another organ. In other words, if you're exercising, it would sure help to have a few extra red blood cells running around to carry oxygen. So it does that. The second thing that adrenaline does is it helps to increase your heart and breathing rate. Yeah, I'll just leave these all here. Okay? Increase your heart and breathing rate. Now, don't forget that that's not the only thing that would increase your breathing rate. Don't forget about those acid receptors in the respiratory system too. So these are just helpful things. They work together. And then the last thing that adrenaline does is it kind of it helps decide which blood vessels to open and close. So if you were running, it would say, okay, well, we need more blood to the legs. We're going to open up those blood vessels. Maybe we don't need so much blood to the stomach right now, so we're going to close some of those. And so that your blood can deliver the things that are needed for all that work going on in your legs right now. So it kind of helps with this, vasoconstriction and vasodilation in different places depending on what kind of exercise you're doing and what kinds of blood demands are needed in that particular area. So in terms of measuring your blood pressure, what I'd like to do, just real quick, is just kind of remind you of how blood pressure is measured. So you will measure your blood pressure today, and you're going to get two numbers, like 120/80. The reason I picked that one is because that's a really good blood pressure number. What do you recall the top number is called? Right. That's called your systolic pressure. And you learned on Friday, I think, what systole meant. And systole means contraction of the heart. So what your systolic number is the pressure measured in millimeters of mercury. It's the pressure when your ventricles are contracting. So you can imagine as your ventricles contract, it's going to shoot blood out. There's going to be an increased buildup of pressure. So this is really your maximum blood pressure, and it's the blood pressure you find in your arteries when you have this contraction of your ventricles. Dystole. What's dystole? Dystole is when your heart is relaxed. So your diastolic number is the bottom number. And that's the pressure in your arteries when your heart is relaxed. So this is kind of the minimum pressure. It doesn't get any lower than that. So this is when your heart is relaxed. And it's a measure of the dystole of your heart, the pressure the pressure in your system when your heart is relaxed. If you get into this range right here, maybe say a 140/90 or a 140/100, you might be considered to have hypertension, high blood pressure. And then the same kind of on the low end, you can have low pressure. Here's a good little chart, I think, that kind of shows you a little bit about what these blood pressures are like. And you can kind of see that if you have a blood pressure between 90 and 120, that's the green here, for a systolic number, and a diastolic number between 60 and 80, that's great. That's a good normal blood pressure. If you have a systolic number above 140 or above 90 on the diastolic number, that would be considered high blood pressure. And then you can even see what your low blood pressures might be. A number of 90 or less for the diastolic number, or 60 or less for the your diastolic number, 90 and 60. So you can kind of, if you want to look at this recording, you can read that little screen, and it gives you a nice summary of what's happening here. Okay?